Yes, that's right, folks. It's time for another thrilling installment of the Industrial Revolution. Everyone's favorite subject. So, I believe we paused here. We're talking about the tinkerers, as they're sometimes referred to, those artisans, craftspeople who were already using sort of primitive technology, levers, pulleys, different weights measures, etc., and made some of the major innovations and advances in the direction of more and more sophisticated technology that leads in turn to actual industrial machinery. But I think I ended by saying that some of these people had more scientific training, however unofficial, than has been often realized. We got to this too already, didn't we? So we did get through here. So remember the challenge and response bottleneck idea here, which really did happen, but not just in this sense, kind of all across the board in England and elsewhere. Anytime you have a complicated system that has a number of steps in the process, innovating and speeding things up in one area doesn't do any good unless you speed them up in all areas. So the bottlenecks actually created huge pressure on those bottleneck points and gave a challenge to the whole country, Britain, and then others, but also a challenge for individual entrepreneurs looking to make their way, make a fortune, make a name for themselves by inventing the power loom, as Edmund Cartwright did in 1785, etc. Other such developments of importance: the Bessemer process, a big jump forward in steel production, making it again much the process smoother, cheaper, more efficient, which is not only a savings of money, as we'll see, it means profits at the other end in sort of basic economic terms. So innovation, why was it so important? Well, for a number of reasons. The most important to any proprietor of such a business, whether it's steel or textiles or whatever else, is that if you don't innovate, your competitors certainly will. And if they innovate and you don't, what it means in basic, again, economic terms, is that they're going to undersell you. They're going to be able to produce their steel or textiles or shoes or whatever it may be more cheaply, and then they're going to then price them more cheaply than you, and you're going to get all your customers. All things being equal, of course, but that's the basic idea, which sounds somewhat counterintuitive, but I think we know that makes sense, and we'll come back to it. Another major development was the steam engine, and James Watt's particular contribution to it. He wasn't the inventor of the steam engine per se. Actually, in the history of technology, it's quite difficult to pinpoint one person and say, this person invented that. Because you can always go back one step and say, well, okay, but there was a prototype or a partial version of this before, and then there was a prototype of that even before that. So James Watt wasn't the inventor, but he's kind of one of the key sort of spots in the process of development, and improved the steam engine greatly. And the steam engine becomes the major power source for the Industrial Revolution everywhere. And as it says at the bottom, and I think this is most likely true, no steam engine, no Industrial Revolution. So without it, none of this would have taken place. This became the way to power machinery and to produce goods on an industrial scale through an assembly line process in every industry, or almost every industry, over time. Before Watt, before such improvements, and there would be continuous improvements over time, steam engines had the kind of bad habit of exploding, which isn't too good for business, I would assume. There was a certain amount of synergy, a lot of synergy, in more than one way, whereby certain needs, certain resources, certain processes combined to kind of push each other along. And the classic one is the synergy of coal, steam engines, iron production, and railroads. They all had kind of a mutually beneficial, mutually reinforcing element to them. So I've simplified it in the bottom right. The need for coal, right? Coal is what fires steam engines, and right, coal had been used already in Great Britain and other places for a long time to heat homes. So at first they're digging out coal, and the coal industry is there to provide sources of heat. But in the process of doing that, in Great Britain, coal mining companies, coal miners, they eventually dig so far underground to get, at the coal that they haven't accessed yet, and they reach the water table. And I'm no physicist, but last time I checked, water doesn't just flow up. So it became a problem when they got to the water table. They had to figure out a way to get the water out of there if they were to, get any more coal, because they'd already mined all of the stuff above the water table. And this was another example of challenge and response, because there was now a premium on someone being able to invent some type of machine that could pump the water out, so that they could now get beneath it and access and mine the great deal of coal that remained underneath. And this is what eventually led to the steam engine. And better steam engines, as time goes on, bring in more coal. More coal contributes to improvements in iron and steel production. Improvements in steel production eventually allow cheap steel to help many industries, including the railroad industry. And steel and coal and steam are crucial in trains and the railroad industry, building locomotives and an entire railway system. Looking at early factory life, the factory itself looked like on the outside and the inside. You probably aren't surprised at this. It looks pretty chaotic on the inside. A factory, that would be a small factory by today's standards, but that's certainly more than a shop, right? When we think of a shop, we don't think of a building that big. We think of kind of like something more the size of a house or smaller. So factories, certainly just starting with the basics, are much larger places where goods are produced in larger number, with a greater number of workers and lots of machines inside. And it probably was that chaotic and that as dangerous as that looks. And you can imagine the fumes and the smoke and the dust and in these types of facilities. So probably none too safe, none too good for you. Probably lots of there were lots of industrial accidents. In the bottom left, you can see one of the painting of one of the early industrial towns. Smokestacks are sticking up all over the place, already belching out smoke. Professor Perry talks about the resulting explosion in economic production and productivity, which transformed society with breathtaking speed. And so the factory system of mass production was underway by around the 1780s and continued to pick up steam. Get it? Anyway, bad jokes are sometimes funny because they're so bad. So the factory system of mass production, let's get into a little more detail on this. This represented once it got up to speed, a productivity and a profit explosion. So what are the various components of a factory system of mass production? First of all, assembly line techniques. Today, we tend to, I believe anyway, right, maybe it's just me, think of things like a conveyor belt that's putting together a chassis of a car, a Toyota Camry or whatever it may be. So assembly line process, that's of course an anachronism because they didn't have the conveyor belt type thing then, but the logic is the same. And the logic is that the production of the product, whatever it is, no one is making it by the whole thing by hand any longer, like we saw in the shoemaker's shop in pre-industrial times, that each person, each step of the process is done piecemeal, one step at a time, but by a different person, or a group of people, different people. So whether it's a conveyor belt or people just passing products, from handing off to someone next to you, it's the same logic. In fact, in a class fairly recently, I had someone come up after class, a recent immigrant to our country, and said, when you were talking about the assembly lines in the Industrial Revolution, about how in the 18th century it was often sort of passing it off hand to hand without conveyor belts or more modern machinery that moves the process along. The person said that they had just quit a job where they were assembling cell phones, and they did exactly that. Someone handed them the cell phone as far as it had gotten, and their job was to put in one piece and hand it to the next person on the assembly line, and said that's what I did all day long, is just put in one piece, the same piece, in the same place all day long, hundreds of times, and then went home. So even today, sometimes assembly lines for high-tech things like cell phones, smartphones, even have kind of the old-fashioned assembly line way of doing it. So assembly lines are crucial on this whole process. So is a division of labor, and they go hand in hand. That just means that, again, the workers only do one step of the process and send it on down to the next person, and so it's a whole chain of events set up in a logical order, so that the product is put together, in its final form, in piece by piece, step by step, with the proper steps to maximize efficiency. Mechanization, just fancy word for increasing use of machinery. The machinery in this rather blurry-looking factory, I think it's a steel mill. I think so, but looks primitive. But of course, it's from a couple centuries ago. So, but this was high tech and modern, cutting edge at the time, and this was extremely innovative. Everything in there that looks like a machine and was a machine, was cutting edge technology at the time, and so machines become increasingly important to the efficiency of all this, to making profits by cutting production costs. And there are already some of the classic modern problems in evidence here, which means, for instance, that sometimes workers are put out of work by machines who can do the job more efficiently without them, or with fewer workers. So that was already an issue to some degree then. And what's also true is that as the technology, the machinery, gets more high-tech and more complex, workers tend to do kind of less. So as the technology gets better and better, workers are reduced to kind of just being there to kind of guide the product along, to press a button here and there to tend the machine. But it's the machine more and more that's doing all of the physical work and all of the mental work that's kind of programmed into the machine. So the worker, as the Industrial Revolution proceeds and gets more and more complex in the sophistication of the machinery, the workers are less skilled. They don't need as much training. They don't need to know as much about what they're doing because the machines are taking care of more of it. Replaceable and interchangeable parts. This is something that's often left out. I don't think our textbook mentions this, but it's absolutely crucial for an industrial system, factory system to work. Modern industry, is not even doable without it, and it's obvious, but we just don't think of it very often. This meant that parts have to be made in a standardized way, so all the same parts are the same size. Otherwise, everything will come to a literally grinding halt, and the conveyor belt, the assembly line, the assembly of whatever product it is just won't work. So we're so used to this, it's out of sight, out of mind. But almost nothing these days, I mean, there are exceptions, is that we buy at the store. If you look around the room where you're watching and listening to this right now, right? How many things in the room can you count that aren't made through some sort of factory system of mass production, right, with interchangeable parts? So your computer certainly wasn't hammered and put together, and the size and shape of it handcrafted by an individual, a master craftsman computer maker. Right? That would be absurd. This is made by technology and by machinery, and the ability to kind of measure and cut. In our case now, it's plastic and steel and things, but wood in those days, and textiles. So the patterns for leather, for shoes, right, comes out sort of the same from the machine. All the way down the line, so hundreds of shoes are being spit out on the other side of the assembly line that are the exact same size and the same dimensions, right, on every single one. Not that there are never errors in the system and products that are defective here and there, but the system is designed to make cookie cutter parts. You just couldn't have an industrial revolution, products produced this way on an assembly line, without not only the concept of Interchangeable Parts, but the technology to be able to measure and cut various materials, down to fractions of an inch, a hundredth or 1,000th of an inch, whatever, however specific you need it to be. Excuse me. Of course, all of this was expensive. More work being done in bigger buildings, right? Their overhead costs. You have to heat and light the building if you're the owner, right? The labor costs. It's more workers in one facility now, sometimes hundreds, eventually into the thousands. More and more expensive high-tech machines, sometimes into the hundreds. Sort of all jammed into this big building. All of that requires a great deal of capital. So this also creates a challenge and response situation in financial markets. Financial instruments and mechanisms are being there's a pressure to create new ways to finance things. So banking and finance have to get innovative and creative as well. This is another potential bottleneck. If you've got an entrepreneurial idea, a product to produce, and you have you have some of the machinery, and you have workers will want to work there. The idea is viable, but you don't have enough money, right? There's a bottleneck right there. So if the capital can't get where it needs to go, then you have a slowdown, and the process is certainly inefficient. So capital, financial markets are making innovations as well. We'll get kind of back to that as we go through this. But capital also is somewhat misleading. We tend to think of capital as a synonym for money, and that is, of course, one of the dictionary definitions of capital. But the capital in capitalism often means something more specific as well. And that is, and I think it's important to note this, and that is that capital, right, in a more technical, narrow sense, doesn't just mean money. It means the profits that you make in a capitalist industry like steel, but also what you do with it. A good capitalist doesn't take the profits at the end of a year and blow it all, in Tahoe or Vegas, and make $3 million in profits, and then just, hey, I can just go on a spending spree now. The good capitalist takes maybe not all, but much of that money and plows it right back into his own business and reinvests to improve the machinery, to improve the assembly line process, to find ways to save money to make things more and more efficient. Now, of course, such a business owner, if he becomes a millionaire for the first time, probably buys a new, big new home. I'm not saying they don't take some of the money to, improve their lifestyle and standard of living. Of course they do, but much of it has to be put back into the business, and we already know the reason why. It's because if you don't, your competitor will. And if he does, and he's able to, he plows the $3 million in profits, let's say all of it, except for what he needs to live on, back into the business, and he through that is able to do research and development on new machines that can produce at a faster and more efficient rate than yours, you're in trouble because he's now going to be able to undersell you in the market and take your customers. So this system is remarkably successful in many ways, but that doesn't mean that everyone that started a business, that opened a factory, ended up being a success story, because there's intense competition. Capitalism is partly about competition, and it sometimes can be brutal competition. So there were plenty of businesses that failed, and so the pressure is on. Capital is of the essence, meaning reinvesting it, plowing it back into your business. I sound like a business instructor here now. What makes this combination so potent? Lower prices. All right, what? Why would you want to charge lower prices? This is where I said it gets a little bit counterintuitive, because you think, well, wouldn't you like produce a product and then sell it for as high a price as possible? Yes, up to a certain point. And there are some products, in every society, in every economy, where the strategy does require, or you've gone down the road where, okay, our product is going to be sold at a higher price, and advertise something like a, I don't know, Mercedes. And so the idea is, hey, it's worth spending $1 million on a Mercedes-Benz because it's a better car. So they actually are trying to sell, more cars at a higher price, and not undersell. Although once in a while, if when they have other competitors that are doing the same thing, they might try to undersell them because they're selling a higher quality product as well, or at least they're saying they are. You either sell a higher quality product, or you convince everyone that you're selling a higher quality product. Either way, it doesn't matter as far as your pocketbook and profits are concerned. To convince the people, it's the same thing from your perspective, not from theirs. But I think the classic way to understand how industrial capitalism works, to keep it simple, is to understand that really it's more about underselling, sort of wanting to charge lower prices. And that gets us back to the process of the assembly line process of production. All the things that are on our screen above, and that is that the more money you can save in production costs, labor costs, overhead costs, heating, how much you pay your workers, how efficient your machines are, how quickly it can produce the final product, from the start of the assembly line to the other side, spit out the door, on its way to market, on a railroad, etc. The more money you save at that end, then you can afford to undersell your opponents and price your product more cheaply. And again, why would you want to do that? Well, simply, most of you already figured this out, or all of you have, but the idea is, if you sell your product cheaper at a lower price than your competitors, you're going to get their customers. All things being equal, and they're not always equal, but all things being equal, why would somebody want to pay more for the same type and quality of steel when they can pay less? But if your competitor doesn't have a competitive advantage, say doesn't have the same efficient machinery you have, he doesn't have the luxury of going as low with the prices, because he will lose money. Wait a minute, I can't sell it for my steel that cheaply, because if I do, I calculated here my production, overhead, labor costs, other costs, interest I'm paying on loans is so high, I'll lose money. That's the point. So these businesses, these industries, these factories are always competing with each other to try to lowball the other one. You want to lowball them. Think Walmart. Right? Walmart has a bunch of cheap shit, in a huge store, and everybody goes there. Right? That's why everybody shops there. They don't shop there for quality. They shop because they get things at a cheaper price. Now, Walmart doesn't produce things. They're merchants. but it's still the same idea. They're underselling their competition because they have lots of advantages, partly mainly because of their size, in being able to save money. Kind of, they don't really have an assembly line, but sort of at that end, right? The preparation end, they're able to save more money than, say, your average mom and pop store in getting things on the shelves and do it more cheaply, and that's how they can afford to undersell their competitors, sometimes mom and pop stores, sometimes bigger ones, and get everybody's customers. So think Walmart. That's sort of the classic way to think about the way this system works in a simple way. So again, there are exceptions, but the best way to understand a factory system of mass production in an industrial capitalist system is you're trying to cut costs through more efficient and cheaper production in your factory so that you can undersell, lowball your opponent. Why doesn't a country reverse and go a different way, go backwards once it goes through an industrial revolution? It might be hard to do anyway, and it's happened before, because of wartime devastation and such. But no country willingly goes back. I mean, it could happen theoretically in the future, but to my knowledge, it hasn't happened anywhere in the world yet. And there are always people that want to go back, by the way. So, and they're usually workers. But, of course, the workers don't get to make that decision. They don't have the power to do so. But some of the workers, or the poor in general, want to go back to pre-industrial days. Not all of them, but some of them do. And we have, lots of documents and letters and papers and diaries where they're lamenting the loss of kind of a more simple, old-fashioned, the day when the small village, right, didn't have the clanking sounds of machinery and the smokestacks bellowing noxious smoke all over the place. And you see this kind of nostalgia, really, for the old days. And that, I think, is the problem in assessing this. Not all of it is nostalgia. It's possible that in that particular area, or in all areas, that life was better before modern industrial production, when things were made by hand and the technology was simpler. It's possible, but nostalgia is often the way such documents, if you look at them, read. That we tend to look back on the past, unless it was a period where something really traumatic happened to us, or the society. We tend to look back on it fondly and remember the things that were positives and kind of forget the negatives. And as I said in the last lecture segment, we also then to really conclude that the lives of workers were awful under this new industrial system, we'd have to compare it to what their lives and work life, daily life, home life was like in the old pre-industrial economy in largely rural towns and villages. And historians are at odds with each other even to this day on that issue. But there are some that think that this was actually a step up from that pre-industrial life, which doesn't in any way mean that their lives were great. It's clear that they weren't. The jobs here, the lifestyle here is difficult and often unhealthy and unsafe, etc. But the point is that if you go from having a lifestyle that's awful to having one that's just kind of sort of bad, that's still a slight improvement. You'll take it. So what we look at, if we just look at the Industrial Revolution in its early years, Great Britain, other places a little while later, it looks positively awful from the workers' perspective, but that's really misleading because we'd have to back out to really get an accurate assessment of how it was for them. We'd have to back out and look at a longer timeline and see what life was like for them before. But I've digressed because the question at the bottom of the screen is why you don't reverse an industrial revolution. And I should say and not and. Just try to ignore that. The reason is because the government won't let you. It's not the capitalists, though they don't want to go back either. At least the successful ones are making lots of money, becoming millionaires. And they have more say than the workers do, of course. But it's really the government. a government, at least in the capitalist system, sees the benefits to the government. They see that greater technological advance, a modern economy. Let's take steel as a great example, because we can picture this easily. If we move a little bit ahead to the end of the 19th century, right, steel production, once a country like Great Britain, the United States, Japan, sees that how much steel we can produce through these modern techniques, through modern industry, they start to quickly realize, wow, this is our ticket to the top. Our country, if it's not already there, can be an economic, military, and political powerhouse because of our industrial economic prowess. That is too tempting to put aside. You're not going back, however many of your population would prefer to, even if it's nostalgia. A government is never going to willingly do so. The potent impact of division of labor, we've already really kind of talked about this. Adam Smith had said in Wealth of Nations back in 1776 that he's being paraphrased here by another current scholar, deplored the deadening effect of the division of labor and called for government intervention to raise workers' living standards. One of the many ways in which Adam Smith is misinterpreted, which we talked about to some degree when we dealt with the Enlightenment, is that people think his book is just a paean to capitalism and kind of a greed is good mentality and philosophy. It's not at all. Smith actually was greatly suspicious of capitalists, didn't trust them, hated the idea of monopolies, which he thought wasn't in the spirit of capitalism free markets, which it isn't, and also believed, contrary to popular opinion, people have usually never read his book, that he didn't think there was he didn't think it was correct, useful, morally right for any government intervention into the economy, or at least very little. That's not totally true. He thought it should be limited, but he actually, for instance, before his time, ahead of his time, was already talking about the need for a public school system, for instance. About 300 or so pages into Wealth of Nations, he actually says that if we don't do that, if the government doesn't intervene and educate children of parents that are working in factories and the factory workers themselves, we're going to have human beings as stupid and as ignorant as it's possible to create. That's almost a direct quote. So Smith was well aware of the kind of mind-numbing effect of this kind of rote, repetitious work on the assembly line, as Karl Marx would become aware of, as we'll find out later in another unit. We're going to skip that. We don't need to get into that much detail. Working conditions, again, they were awful, but it's relative to what came before, of course. David Landis, already quoted, talks about workers broken to the inexorable demands of the clock and machine. So among other issues was the fact that once workers go from, say, working on a farm that's their own, let's say they lose their land to foreclosure, they move to a city, they know there are jobs there, everyone in the family gets a job in a factory, including the kids. Child labor was very much still legal in that era. They're now kind of the pace of life is different. They have to now keep up with the machines. When you owned your own farm, you were going to work, but you could kind of do so at your own pace. Now the pace is dictated not by the seasons, harvest time, or the sun and the moon, or the weather, rain, sunlight. It's dictated by the boss and by the factory whistle. So, and how fast does the boss want you to work in this new type of system? Faster, right? Well, but I'm already working faster, right? Produce more, work harder, and do it in less time. So the pace of life is speeded up against the will of the workers. So there's new hardships here. Surveillance, greater supervision of work, along with the division of labor, and other issues. Interchangeable parts, we already dealt with this, but this first, the whole idea and the ability to create the technology to do it, to make replaceable interchangeable parts exactly the same size, cookie cutter cutouts of every other part. It started in weapons manufacturing, which actually makes perfect sense, the second question there. And it started really in France. The French were the first to really see the usefulness of this, or to be able to put it into play. Why does it make sense that it started in military hardware, guns, cannons, and so forth? Because this happens a great deal in history. We'll see it again before this class ends. What does a society do, a country do, that's more serious than warfare, more important to its survival and well-being than warfare? That's not to say that war is a good thing. That's not what I'm saying. But warfare has to be taken deadly, pardon the pun, seriously, because of its potential for loss of life and limb, and loss of your country. You could get conquered by a neighbor. So nothing is actually more serious than at least potential warfare. So what I'm saying is the needs of war, the potential of a war, has a great way of sort of sharpening and focusing minds and saying, we got to get better at this. Which brings us back to, yes, you guessed it, the competitive European state system. Just like in a business, if you don't sort of keep up with the pace of technology, you're going to get run out of business. Well, when you're competing politically, militarily, economically with other countries, if you don't innovate and keep up with the pace of military technology, you're probably going to be defeated in the next war against a country that is keeping up. So, so many things in history that eventually have civilian application in the private sector of an economy are first developed, invented, the research and development done by the government, by the military, and then turned over after the fact for civilian use, for use in private business. So it's not in any way a surprise. It's actually the norm through the long course of human history that technological innovations, other types of even financial innovations are spurred on, motivated by war, or at least, again, possible war. So it started in France, and then the Americans stole the idea and stole the technology. Again, the technology of being able to cut wood and metal to the same approximations every single time. So the machinery had to be there in place to make guns and cannons with the same size barrel for the same model in this cookie cutter way. But the Americans stole it and actually went farther with it than anybody else. This actually became known by the early decades of the 19th century as the American system of interchangeable and replaceable parts, which is odd because it was really done first in France, and the Americans stole the technology. Industrial spying and espionage goes way back in history. Every country's always done it, but it's because the Americans, our country, sort of took this further and ran with it and got ahead of everybody else faster, even though it was originally France that had sort of developed all of this, but it spread everywhere eventually. Edward Baines, who wrote in 1835 A History of Cotton Manufacture, which I won't be reading anytime soon. I've looked at excerpts from it, like this little blurb here, but it doesn't sound particularly exciting reading. I could be wrong, but it's not something I don't even think I have a copy of it, but it's not something that is on my reading list. Nonetheless, Baines was a significant intellectual figure, writing about, noticing, paying attention to many of these new developments, and sort of putting together some principles of kind of understanding where this was all leading and heading before many others. So he said in the above-mentioned book, the introduction of the factory system, when that system had once been adopted, such were its pecuniary advantages that mercantile competition would have rendered it impossible, even had it been desirable, to abandon it. So he's saying in a much more fancy way, he's probably smarter than me, damn him, the same thing I already said, which is that you're not going back from an industrial revolution. So Baines sort of wrote a book on where this was taking Great Britain, and he realized it's taking them further and further into and through an industrial revolution, and there's no way that we're going back for better or worse. Looking at a couple of the major success stories in the early years of industrial development and production in Great Britain, at the top of the list is Josiah Wedgwood, who wanted to astonish the world, as he said it. And he industrialized, of all things, the pottery industry, though he did sort of take the route of kind of the Mercedes-Benz strategy of producing a high-quality product through industrial techniques and processes, or at least saying that you're doing that, and selling a high-quality product at a higher price than your competitors because it's worth paying more for Wedgwood products. That was the idea, and it worked fabulously well. But this was assembly line stuff, not handcrafted. I think there were some elements that might have been handcrafted, but a lot of this was assembly line techniques. His first factory opened in 1769, had 200 workers, and his business was a model of discipline and efficiency of the kind that we've already noted is necessary for success in this new economic climate. He wanted his workers to be like machines that cannot err, which is somewhat ominous sounding, of course, because he wants his workers to be machines, but they're human beings. But he wants them to be like the machines, which don't make mistakes. Of course, machines do make mistakes, but they don't make them very often. Humans tend to make them more, at least good machinery, right? And so he's saying we have to, as much as possible, find a way to match up the consistency of the machines with the consistency of the workers, or this thing will break down. He was certainly right, but it's to put it mildly, he's dehumanizing his workers, whether he meant to or not. What's most famous about Josiah Wedgwood, however, is his grandson, a guy called Charles Darwin. Josiah Wedgwood was the maternal grandfather of a guy we'll meet later in the class, who you've heard of course, named Charles Darwin. Darwin came from an illustrious and wealthy family on both sides of the family. John Marshall, not to be confused with his namesake in the United States, who was the first great Chief Justice of the Supreme Court in U.S. history. This is the John Marshall that made millions in linen manufacture, so type of textile production. His mill, this first one, took up over 2 acres of territory, which was gigantic for the day. Workers numbered in the thousands at his mill, at least in time, and he became extremely wealthy. You see pictured, crude drawing, but a picture on the left of his Temple Mill in Leeds in England, in kind of what became or is becoming the industrial heartland. So there are other examples I could give, but these are 2 of the most successful capitalists, industrial producers of the early Industrial Revolution, John Marshall and Josiah Wedgwood. There was, along with this, another necessary area that needed to innovate and to improve its efficiency, and that's transportation. So we see, again, partly through the idea of challenge and response, that there needs to be a transportation revolution here in Great Britain and everywhere else that is going to industrialize for it to work. So another bottleneck problem is here. If you can churn out lots of goods from factories in one day, but the transportation and getting to market doesn't sort of increase and improve with increases in production, you might as well not produce stuff as fast. What's the point? It's going to stack up and collect dust in warehouses. So transportation was also of the essence. So all these things are pushing each other, again, kind of mutually connected to sort of greater and greater effort and to greater and greater effectiveness, efficiency, better technology. Turnpikes in Great Britain were an example of this. Turnpikes we still have in the U.S. Now, here and there. But it's like a toll road. In California, we have a couple of, I think, sections of highway in Southern California that are toll. And usually it's bridges in Northern California, like the Bay Bridge. But on the East Coast, there's much more of that still, but a turnpike was built by a private corporation, private company, so there's a competitive system in road building. Not all roads were turnpikes, by the way, but some. And this, was the incentive was profit, because then you could and did charge people to, ride, take their carriage, take their wagon, whatever it was, down your toll road, a turnpike. So this was a one simple, improvement in transportation, more and more effective roads. But of course, the big innovation, and steamships come along here as well. At the same time, we're kind of skipping that. The British built man-made canals to connect pre-existing natural rivers and waterways, which of course are still there. People go down those canals now on vacations. We'll take a vacation sort of within England and go on a couple days trip kind of down one of the canals. Still done sometimes, but for recreation now. But these were waterways, man-made, that were originally designed to get products to and from to market. But it's the railroad, of course, that's the big technological and organizational transportation breakthrough and revolution. The railroads are the dominant transportation mode from say the 1830s on into the 20th century. Now, of course, railroads are somewhat quaint. We still have them, but you don't see trains too often. I only see a train on those rare occasions where I'm late for work. Oh, great. The one day I'm running late for work, and now there's a train with 1 million cars, and I'm stuck, waiting for it to go by. But anyway, now we have semi trucks that carry a lot of our products, and airplanes, and huge container ships. But and they had, again, steamships in those days. But on land, the way to transport goods on a large scale, economically, cost saving, efficiently, quickly, was the railroad. So this was an absolute revolution in transportation. The two most famous and most influential railway entrepreneurs were George Stephenson, you see on the left, and a guy with the great name of Isambard Kingdom Brunel. That was actually his real name, who started and built the Liverpool and Manchester Railway and the Great Western Railway, respectively. So, but they built even more than that, and other systems. And of course, there were other railroad entrepreneurs competing with them. And you can kind of see in the map in the middle that in a fairly short amount of time, railroads crisscross England, and there's a whole big, complicated network of railroads. So the railroad is the main answer to the transportation bottleneck, or potential bottleneck, and it's an enormously important one. Railroad companies, railroad executives and entrepreneurs become powerful people. The United States is a great example of this, but in other capitalists, developing industrial capitalist countries as well. And railroads are sometimes the first big corporations in industrial capitalist systems as well. The first big money businesses, sometimes employing the most people. So in industrial revolutions, the railroads owners, the businesses are often sort of among the most wealthy, the most important, the most powerful, etc. There's a couple of ways to kind of see, I think, the overall importance of railroads. One is that railroads themselves, because they're such an innovation in terms of saving costs, reducing costs, but because you're transporting now more quickly and it's cheaper, it opens up markets. So it leads actually to economic growth. Just the railroads themselves in a capitalist system helps to lead to greater productivity and economic growth. So to give us a simple hypothetical example, if you own a factory, say in London, and before there are railroads, or there's just very few railroads, you'd like to sell your product, widgets, whatever you're making, in the north of England. But when you calculate the cost of sending them by canal, by river, by dusty dirt roads or toll roads, you realize that the costs make it counterproductive to do it. There's no cost incentive for you to do it, because when you add up the transportation costs, you realize by the time my goods, my widgets, get to Northern England, it'll cost me so much that no matter what I sell them for, I won't make any money. I might even lose money. So there's no point in trying to sell there. And let's say the one factory you have already saturates Southern England with all of the widgets anybody needs. So because nobody in Southern England needs any more widgets, and it's not cost effective, profitable for you to sell in Northern England, there would be absolutely no reason for you to build a second factory and produce twice as many widgets and hire twice as many employees. You might want to, because if you grow your business, you can grow your profits, and you want to become wealthier, more powerful, you want to be sort of a bigger success story. But there's no reason to do so. It would be a waste, literally a waste of time and money. But once the railroads go in on a widespread scale like this, you recalculate and you think, holy cow! Now not only is it cost effective, I'd be remiss not to do this. And so now you might have reason to build 2 or 3 new factories, because now it is profitable to send your goods to further and further distant markets, and maybe now you're producing to sell nationally, every corner, nook and cranny of England, or Germany, or the United States. In time, it's now feasible to sell at profitably. So railroads themselves tend towards economic growth for that reason. Also, railroads become central, of course, to the transportation part of this, but railroads kind of help to spur on other industries as well. This is similar to the effect that automobiles will have later on into the 20th century, which is to say that what is a car? Well, a car is made of steel, rubber, oil, and glass, and many other products. So one could, I think, safely assume, and there might be exceptions here, but safely assume that if the car industry is booming, then so would be the glass industry, steel industry, oil industry, etc. And the same is true, maybe to a slightly lesser extent, with railroads. They're made of steel, and they require coal to fuel the steam engine, wood as the crosses on the tracks, lots of timber needed. So all of those industries are spurred on as more and more railways are built, more and more trains, more and more locomotives are built to carry on the increasing scale of commerce in Great Britain and other places that industrialize.